today. Today is a new class for grade 12. Subject is physics. This presentation is for week 6 and this presentation is delivered to you by me, Mr. Khalid. Today we are gonna discuss a new topics. First one is energy transfer. So what's the energy and how we could transfer energy from point to point or from place to place. Number 2 is newtons. What's the relation between newtons, meters and joules? So newtons is for force, meters for distance, and joules for what? Energy. So there is a strong relation between newtons, meters and joules, and we are going to say what's the formula that could control 3 of them. Number 3 is similar to number 2, is the relation between force, distance, direction. Force, distance and the direction of movement, or how the subject can move is or the movement of subject is in the same direction or in different direction. Finally is the gas doing work. There is a good phenomena here. It's very important to see how the gas doing work. Okay, now we will start with the first subject or first topic, energy transferred. So what's the meaning of energy transfer and how could we transfer energy? Actually, as we said in the last presentation, doing work is a way of what? Transferring energy. Doing any work is a way of transferring energy. As we can see in this figure, when you push this car from this point to this point or in this direction, so there is a force, and there is what? Distance. So this car, it should move from, for example, this point up to this point. So there is what? Here is distance S. So we have what? Force. The force to push the car is equal to 300 Newton, and the distance X is what? 5 meter. So as we said before, there is a formula to control 3 of them, which is what? W is equal to F times S. W is energy or work done. Energy is equal, keep this in mind, always energy is a work done. Energy transferred or energy is equal to what? Work done. So W here, it could be by what? It could be work, it could be energy. So it measured by what? Joule. The unit of it is joule. So for both energy, as we said, energy or work, the correct SI unit is to measure energy or work is what? Joule. So the amount of work done is calculated using what? This formula, as we mentioned it before. So here the amount of energy transferred what is controlled by what? This equation. Keep this in mind. Today in this class we will see a lot of formula for different things, for power, for energy, for lots of things. So try to keep all of those in mind, please. So the conclusion here is what? Energy transferred is equal to what? Work done. It's same as the work done. Now we will say what's the relation between newtons, meters and joules. So as we said before, Newton is for what? For force, and meter is for what? Distance, and joules for what? For W. So this is W, this is S, distance, and this is in Newton is what? The force. As we said, W is equal to what? F times S. So this one, it's measured by joules, meters, in newtons. So what's the relation between them? From this equation, W is equal F times S, we can say how the unit of force Newton and the unit of distance meter and the unit of the work energy or energy, sorry, the joule, are what related. They are all related. So we have what here? W is equal to what? F times S. So 1 joule is equal to 1 Newton times 1 meter. 1 joule is equal to 1 Newton meter. This is the final relation. 1 joule of what? Of energy, of or of work done, is equal to 1 Newton force meter. 1 Newton force meter. So the joule is defined as what here? The definition of it. The joule is defined as the amount of work done when what? When one force or a force of 1 Newton force moves a distance of 1 meter in the direction of the force. It must be in the same direction of the force. Okay, here is an example. We will take this example to explain what we have discussed before. I think this example is located on the same page. Yes, on the same page of this topic. So in first one, or first example here, number 1. In each of the following examples, explain whether or not any work is done by the force mentioned. So there is a force mentioned. This force, we need to explain, is this force doing work or not? It depends on that force. So we have 4 sections A, B, C, and D. Section A, for example, you pull a half sack along rough ground. So you pull a half sack along with what? Rough ground. So this one is what? A kind of work. Yes, it's work done here. There is a work done here. So section A, yes, there is a work done against where? Friction. There is a work done against friction. B, the force of gravity pulls you downwards when you fall off a wall. So this here also, and this one work, this one is also, there is a work done. Because what? The gravity does work in making you go faster. Okay, so A, there is a work done. B, there is a work done. C, the tension and strength pulls on a stone when you will it around in circular at steady speed. Here there is no work. Why? Because the stone remains what? Remains constant. At constant what? Distance. So distance is constant. From where? From the center of what? The circle. So there is no work done in section C. Same as in D is the same. So there is no work done. Now we will take another example to explain the relation between W, F, and S. So example number 2, we have in this example, they said a man of mass 70 kg climbs stairs of vertical height 2.5 meter. So what we will do here? We need to calculate the work done against the force of gravity. Take J is equal to what? 9.81 meter s to the power of minus 2. So what we have here? We need to calculate what? The work done, W. The work done is W. This is the question here. So we need a force and we need what? Distance. The distance of vertical here is what? 2.5 meter. This one is 2.5 meter. So what we need here, we still need what? F. To transfer this one to the, the mass to the force, we need to time it with what? The gravity here. So W is equal to what? Is equal to 70 kg times 9.81 times what? The distance is 2.5 meter. So the final result, it should be approximately 1700 joule. The energy needed is what, or the work done needed for this one is 1700 joule. Okay, now we will move to another title, which is the force, distance, and direction. Here in this subject, we will say what's the relation between force. There is a strong relation between force, distance, and what? Direction of the distance. So there's a direction for the force with what? Distance. Are they the same? Are they in the same direction or in opposite direction? So for force, distance, and direction, it's important to notice or to appreciate that what, for a force to do work, any force to do work, there must be movement in the direction of the force. So this first one need to keep in mind, there must be a movement in the direction of the force. Second, put F and distance S, force, both of them, F and the distance, moved in the direction of the force, are what? Vector quantities. They are vector quantities. You need to keep this in mind also. So first one, to control the relation between force, distance, direction, we need to keep in mind that there must be movement in the direction of the force. Second, both force F and distance S moved in the direction of what? Of force, are what? Are vector quantities. Okay. So now you should know that their directions are likely to be important. Their directions are very important. What we say here, it's easy to explain by examples rather than those short notes here. So we will go through 3 different examples in figure 5.5 to illustrate this, and we will consider 3 examples involving what? Gravity, involving the gravity. So now we will move to this example or this figure. This one here, we have 3 different examples, different forces, movement of forces. This is a force like this is another force like this, and this is the direction of movement, and this is the distance, and this is another example here. They are a bit different. So first one, in first example here, number 1, you are going to drop what? A stone with weight 5 Newton. So there's a stone here from the top here up to the bottom. You will drop it here from this point, okay, to this point. So the force is where? Is vertical in this direction. So what's the distance? So 5 Newton from the top of what? 50 meter high. 50 meter high from this point. So the distance from here up to here is what? 50 meter. 50 meter. So we need to calculate what? The work done by the force of gravity. The force, this is the force of gravity. So gravity will take the stone where? Down, vertical, downwards. So we need to do some notes here. Force on stone F is equal to what? The force of a stone to take stone from here up to the here. So what's the force effect on it? Force on stone F is equal to what? Ball of gravity. It's ball of gravity on what? On the stone, which is exactly equal to what? Weight of what? Stone. Weight of stone, which is equal to what? 5 Newton in vertical downwards. In vertical downwards. So what's the work done? Sorry, before that we need still what? We have the relation W is equal to F times S. Now we figure out what's the value of F. F is equal to the weight of a stone, which is equal to 5 Newton. And next we would need to find or figure out the value of S. As we said in this example, a stone is dropped from the top of 50 meter high. 50 meter high. So the distance moved by stone is equal to what? 50 meter is equal to 50 meter. Where? In the direction of vertical downwards. In vertical downwards. So it's easy now to find the work done, which is F times S. F and S are in the same direction. F in this direction, S in the same direction. So we just put F times S, which is 5 times 50 is equal to 150 joule or joules. 250 joules. Now example number 2 is a bit different. There is a slightly different from number 1. Here a stone weighing 5 Newton rolls 50 meter down a slope. Down a slope is not in vertical way. So the stone is moving from this point here to this point here with distance of what? 50 meter. 50 meter down a slope. What is the work done by the force of gravity? What's the work done by the force of gravity? So where is the force of gravity on this? The force of gravity is vertical down. It's vertical downwards. The effect of gravity is in vertical way downwards. So force on stone F is equal to what? Same as the previous one here, is ball of gravity, which is exactly weight of what? Of a stone, which is equal what? 5 Newton vertically downwards. Now what's the distance? Is the distance 50 or the distance 30? Which one of them? Is it the distance with the slope, or what the distance with the same direction with the force downwards? Distance moved by the stone slope is what? 50 meter. As we can see here is the 50 meter. Okay. Move it in the direction of force is what? But the distance moved in the direction of the force is what? 30 meter. 30 meter. So which one we are going to take? We will take what? This one. Because the force and the distance must be where? In the same direction. They are moved in the same direction. So we will take this distance and we will cancel this one. So the distance or the work done is equal to F times S, which is 5 times 30 is equal 150 joules. 150 joules. Now, another example here is different, slightly different from, or a bit different from previous one. We have a satellite orbit, orbits the Earth at a constant height and at constant speed. So what we have here, a constant height is constant, and the constant speed. So the weight of satellite, this satellite here near to the earth, the satellite here is what is 500 newton. This is what F. So the weight of this, or gravity pulling this satellite, is equal to what? 500 newton. So what's the work done by the force of gravity? What's the work done by the effect of gravity? Force of satellite, if it's equal to what? Same. It's equal to ball of gravity, which is equal to weight of satellite, which is equal 500 towards where? The center of the earth. It comes to the center, to the earth. For example, this point here. Okay, so now what is the distance here? What's the distance or the relation between F and S? What's the distance moved here? As we said here, they are, or it's a satellite orbits at the earth at constant height. So the distance is what? Constant. There is no movement. There is no movement and a constant speed. The satellite are moving at constant speed with constant distance. So S is what? 0. S is 0. Distance moved by satellite toward the center of Earth in the direction of the force is equal to what? 0. So the satellite remains what? Constant. Distance from the Earth, so it doesn't move. There's no movement in the direction of what? Of F. F is down, and the satellite doesn't move down. It's staying here at this point in this orbit here. It keep moving where? Here with constant distance. Distance is S. So S is what? 0. There is no movement. So the work done is equal to what? W is equal to F times S. F times S. F is 5 Newton. S is 0. So the work done is what? 0. The work done is 0. So here we have 3 different examples of movement for or explaining the force, distance, and direction. Actually, those examples in figure 5.5 explaining what we have said in those points here. So please try to keep those in mind. It's very important. Actually, we have another type of or another situation of movement, of force movement. In equation W equal F times S, or the work done here in this equation, the distance moved is here, it's equal to what? The displacement in the direction of the force. Okay, this is the normal case, what we have discussed before in those examples in the last slide. Now we will have a special case here. We will have a special case here. Suppose that the force F moves through a distance S which is at angle theta to F, with angle theta to F. So this is an F, and F is making angle theta with what? Direction of motion. Direction of motion, which is the distance traveled, equal to what? X. The distance traveled, for example, start from this point up to this point is what? X. So now here the work is different. The work is different because what? The force is not in this direction with this way, with this direction or motion. F is not in the same direction with what? F. Why? Because this one is the direction of movement in this way and the direction of movement of S in this way. So there is an angle between F and the direction. So the work done here is equal to what? To determine the work done by the force, it's simple, or it's easy to determine what the component of F in the direction of S. As we have discussed before, the component of F is equal what? F cosine theta. F cosine theta. So the work done is equal to what? F cosine theta times S. The difference is with what? With F. F has what? A theta or angle theta with what direction? So the total F is equal to F cosine theta. F cosine theta. Or simply you can say what? F is cosine theta. F times S cosine theta. They are exactly same. Say write this or this. They are same. Okay. And worked example 1 shows to or how to use this equation. Now we will take an example to explain this special case of what W is equal F times S. So now we have, for work done, we have two situations. The normal one, that the force is in the same direction with the force F. F is with the same direction with motion, or the direction of traveling for any subject, which is equal to W is equal to F times S. And the second one, suppose that the force is with angle theta with what? With the direction. So now or here the work done is equal F cosine theta times S. Okay, let us take this example here for more explanation. So we have what? In this example we have a man pulls what? This man pulls this box of weight, of some weight here, in horizontal ground using what? A rope. With the horizontal ground using a rope. The force provided here by the rope is, the force is what? 200 Newton. So F is equal to what? We have F equal to 100 Newton. Okay. And this force making an angle of 30 with what? With the ground, or the direction of movement. The direction, say this man is moving from where? From this point to this point, for example. So the force provided by the rope is 200 Newton at angle of 30 to what? To the horizontal. Calculate the work done if the box moves 5 meters along the ground. 5 meters along the ground. So as we said in last slide, step number 1, we need to calculate the horizontal component, the horizontal this one, the horizontal component of what? F, of F. So this is F, this is the direction of movement, or this S, distance, and this is an angle. We need to find this component. So the horizontal component is equal to 200 cosine theta, 200 cosine 30, which is equal to 173 Newton. So F cosine theta is the component at an angle theta to what? Force F, to the force F. Step 2, we need to calculate what? The work done. So now we have what? F. We have F. So if 200 Newton is not the total F, because it's making an angle 30. So the total force is equal to what? As we said here, F cosine theta. F cosine theta, 200 cosine 30, which is equal 173 Newton. Step number 2, now we calculate what? The work done. The work done, as we said before, is equal to what? Force F times what? Distance moved. This is the distance moved from here to here. So it's equal to what? 173 times 5, which is equal to 865 joules. Just keep in mind or note that we could have used the equation work done is equal to Fs cosine theta to combine the two steps here, the two steps. You can solve this problem here in one step rather than the two steps here by using Fs. This is F, this is S, 200 times 5 meter times cosine the angle here. They are the same, they are giving the same result. Okay, so now we have what, like four examples. This is one example where force making an angle with the distance of movement, and we have three examples here where the force in the same direction with what, with the distance. Now we will move to another examples or another phenomena in physics where a gas doing work. Where is the gas is doing work? Actually, a gas or any gases exert pressure on the walls of their container. Any gas exert what? Pressure on the walls of their container. So there is a work what on its surrounding. There is a work on its surrounding. If the gas expands, the walls are pushed where? Outside. If the gas is expanded, so the walls are pushed outwards. So we can say the gas has done what? Work. Where? On its surroundings. So in the steam engine, for example, in the steam engine, expanding steam pushes what? A piston to turn the engine. This is another example. Third one, and in a car engine, the exploding mixture of fuel and air does the same thing. So this is an important situation. This is an important situation with what? Gas doing work. Actually, in this figure 5.8 shows what? A gas at pressure P. We have a gas at pressure P inside what? Cylinder of cross-sectional area A. So there is a gas here in this cross-sectional area inside this one here with pressure P inside what? A cylinder of cross-sectional area A. This is a cylinder. So the piston is pushed by what? By gas. The piston is there's a gas inside here, so this piston is pushed this distance from this point to this point by what? By gas pressure. So the cylinder is closed by what? Something here with the piston, and the gas pushes the piston distance or distance is. The gas is here is pushing the piston from this point. It was here, now it moved to this distance. So there is an distance S. There is a movement of distance S. Okay, if we know the force F, if we need know the force F exerted by the gas on the piston, so we can deduce an expression for the amount of work done by the gas. How? From the definition of pressure, pressure is equal to what? Any pressure is equal to force over area. It's a force over area. This area here, for example, inside this cylinder. The force exerted by the gas on the piston is given by what? Force, pressure times area. Force here is equal to what? Pressure times area. So F is equal to B times A. B times A. So what's the work done here? The work done is the force times displacement. Force times displacement. So the final equation here is W is equal to B times A times what? S. It's the pressure B inside the cylinder times A, this area, sectional area A, this area here, times what? Distance or displacement. Displacement from this point to this point. So the work done here by this piston is equal to what? B times A times S. Force, which is equal to pressure times area times what? Displacement. This is very important phenomena or another explanation of the relation between or how to find the work done in another application. This is another application. Okay. Now put the quantity A times S is the increase in volume or in volume of the gas. This is what shaded volume in figure 5.8. We call this what? Delta V. Delta V, where delta indicates that it is a change in V. This is delta means change in V. Thus, the work done by the gas in expanding is what? W is equal to B times delta V. Work done is equal to B, pressure, times changing of what? Of V. Changing of V. Here is a, we will take two examples. I think I will leave those examples for you until the next presentation. They are very easy. Please try to think about them. First one, we have a crane shown in figure 5.9. Lift is 500 or it's 500 what? Newton. Newton what? Load. This crane here is taking what? Something from this point. We need to take those things here from this point up to this point, from point A to point B. So lift is it's 500 load to the top of the building from A to B. Distances are shown on the diagram. So we have different distances here. 30 meters from the building vertical to those things here, and 50 meters from point A to the point B, and 40 meters from the ground up where to the top. So we have what here? We need to find what? Calculate how much work is done by this crane. How much the work done. The work done, I will give you some explanation. I'm not going to solve it now. I will solve it later. Please try by yourself first to be familiar with the equation, with the relation between F and S. Try yourself many times. Try first time, second time, third time, and try to solve many problems as much as you can. So this crane are what do you call? This crane is moving from where it was here. Say this one. It was here, and then it will move where? Up to here, to bring this thing from here, this load, which is what? 500 Newton. 500 Newton. So as we said, the work done W, the work done W is equal to F times S. F times S. So what's F here? F is what? 500. 500. So where is the distance? Which one is the distance? Is it 30 meter? Or is it 50 meter? Or is it 40 meter? Which one? So this question answering the first part of this presentation. As we said, the direction of the force must be in the movement of the force must be in the direction of what? Of movement. So where is that direction? Is it this way, or is it this way, or is it this way? I will leave this for you. So to find W is equal to F is 500 Newton, and S with what is what is the distance? Distance where distance, this is F, and the distance of movement of what? Of F. So which one of them? Is it 30 or 50 or 40? Last question here is the same. I will leave it for you until the next presentation. I will give you the key answers. In this figure here, figure number 10 shows the force acting on a box which is being pushed up a slope. So we have a box here. This box is pushed where? Up, pushed up slope. So what we are going to find here, we are going to calculate what the work done by each force if the box moves 5 meters up the slope. So this box is moved how many or how long? It's 5 meters. So we have W is equal to what in general? F times S. This is another or this example explaining the second part when we said there is an angle between the force and the direction. There is an angle between the force and the direction. Previous one, example number 4, explaining the relation between F and the direction. There is no angle. There is no angle. There is only a distance of movement. So this is explaining the first part. The second part, or the special case, when we said there is an angle between F and S, between F and the direction of movement. So we have how many forces here? This is first force, this is the second one, there the third one, and this is the fourth one. We have 4 forces. In each case, or in each force, we need to find the work done by what? Each force. If the box moves 5 meters up, 5 meters up the slope. Okay, so now we have a distance, an angle theta here. First, you need, I will give you a key answer. Okay, it's not a problem. Now we have here what? 90. This is an vertical. This is vertical downwards. This, the weight of what? This box is 100 Newton downwards, which make an angle 90 here. So this angle should be what? 45, 90. 90 with 90 is 180. So theta is equal to what? 45 degree. Okay, so this is an angle theta. So each one of them, of the forces here, is making what? A force, as we said before. F is equal to what? F cosine theta. F cosine theta. For example, this one, where is the theta of this one? 70. I will give you only one answer. 70 here. 70 is what? Vertical on what? This one. F is what? So what's F cosine theta here? F cosine theta. Theta is 90. Cosine 90 is what? Times F is equal to what? 0. Equal to 0. 0 joule. So there is no work done in this on this force here. So in the same way, you need to find the work done by this, the work done by this, and the work done by this. We have four forces here: 70, 100, 30, 100. Okay. Try to solve them until the next next presentation. Inshallah, I will give you the correct answer, or the, what do you call, I mean complete answer. I think this is all for today. Please try to keep what we have said in previous slides in mind, because we have lots of questions here. Try to keep them in mind. Try to distinguish between those situations: movement with angle and movement with the same direction. There is no angle, so each case has a special equation: F times S or F cosine S. And I think this is all for today, and we will see you next week, inshallah. Thank you for listening.